Welcome to the live session for week 6 of assignment 6 of structure, form and architecture, the synergy. This is an NPTEL course and the course instructor of this course is Professor Shubhajit Sadhu Khan. He is currently teaching at IIT Roorkee. I am Shreya Shukla and I am the NPTEL course TA for this course. I am currently doing my PhD from IIT Roorkee. Today we will be doing week 6 assignment 6. There are total 8 sessions and this is the 6th session which will cover the syllabus of week 6. In these live sessions we do previous year questions, not this year's questions but previous year questions where some sample problems from previous years will be discussed. In this session we will do between 15 to 20 previous year questions, and this is so that the students can better understand the subject and they can ask their doubts if they have any doubts. So we will start with the session. So first of all, talking about the terms in the subject, structure, form, architecture and synergy. So structure has a lot of different meanings, but in architecture it refers to the system which is used to support and transmit possible loads on the building to the ground. It gives stability, it resists stresses and strains. Similarly, form has different meanings in different contexts, but in terms of architecture, a form is a three-dimensional object or building that is perceived by a viewer in space and time and made possible by the action of light and shadow. Then architecture is the art and technique of designing and building. Synergy means the interaction or cooperation of two or more organizations, substances or other agents to produce a combined effect greater than the sum of the separate effects. So the syllabus of week 6 included shell structures, trusses and space frames, folded plate structures, membrane structures and pneumatic structures. Without any further ado, we will start with the questions. So question number 1. This image has been given and you have asked to identify what kind of structure this resembles. So this is an image of Archaea palm leaf, and the options are membrane structure, shell structure, folded plate structure or pneumatic structure. So what is a membrane structure? A membrane structure is a structure with a thin flexible surface or a membrane which carries load primarily through tensile stresses. It is a structure that is characterized by a tensioning of the membrane system, typically with the help of a wire or cable, to provide the critical structural support to the structure. As per structural and architectural point of view, membrane structures are light and freeform structures to span a long distance with the minimum material used in the manufacturing. Membrane can also be used to construct roofs and facades, freestanding buildings, building envelopes, skylights, indoor ceilings and or accent enclosures. Shell structure. A shell is a type of building enclosure. It belongs to the family of arches. They can be defined as curved or angled structures capable of transmitting loads in more than two directions to support. A thin curved plate structure shaped to transmit applied forces by compressive, tensile and shear stresses that act in the plane of the surface. They are usually constructed of concrete, reinforced with steel mesh, and it functions both as structure and covering. A shell with one curved surface is known as a vault, single curvature. A shell with doubly curved surface is known as a dome, double curvature. More complex forms of concrete shells have been made, including hyperbolic paraboloids, saddle shapes, and intersecting parabolic vaults. What is a pneumatic structure? A pneumatic structure is a membrane structure that is stabilized by the pressure of compressed air. Pneumatic structures are characterized by slightly higher pressure of internal air above the outside pressure. Higher pressure of internal air above the outside pressure These structures are supported by pressurized air within the inflating building elements that are shaped to carry loads in a traditional manner. The roof membrane of the pneumatic structure is made from rubber or reinforced films using industrial fabrics coated with polymers like PTFE or ETFE. Folded plate structure. Folded plate structures are assemblies of flat plates or slabs inclined in different directions and joined along their longitudinal edges. In this way, the structural system is capable of carrying loads without the need for additional supporting beams along mutual edges. This technique originated in Germany in the 1920s and it became popular to construct roofs for industrial warehouses and public buildings. Modern folded plate structures are typically made of cast in situ or precast reinforced concrete or steel plate. They are used to make roofs or walls or staircases. All these type of structures can be made using folded plate structure. For example, the image given here is of a folded plate structure in wall. So this is an example of a folded plate structure. If you can see the zigzag pattern on the folding like a fan, this is an example of a folded plate structure. Question number 2. Question number 2. Again, one image has been given and you are supposed to identify what kind of curvature is this. And the options given are monoclastic, synclastic, anticlastic, bipolar. So monoclastic means a single curvature shell which can be curved in one direction and comes in the form of barrel vaults or conoid shells. So monoclastic means the curvature is only in one direction. For example, a barrel vault or a semi-cylinder you can say. Synclastic. These shells are doubly curved and have a similar curvature in each direction. Synclastic surfaces are those in which the center of curvature are on the same side of the surface. A dome is a good example of a synclastic shell. It is doubly curved and can be formed by rotating a curved line around an axis. Anticlastic. Anticlastic surfaces are those in which the centers of curvature are located on opposite sides of the surface. Anticlastic shells are doubly curved, but each of the two curves have opposite direction to the other. For example, saddle points, conoids, hyperbolic paraboloid. Hyperboloids are all considered to be anticlastic shell because they are saddle shaped with different curvature in each direction and straight lines can be drawn of the surface. This I hope so basically monoclastic has one single curvature in one direction. Synclastic has two curvatures. It is doubly curved but both the curvatures is in the same direction. Anticlastic also has two curvature but both of the curvature are in two different directions. Example of monoclastic is a barrel vault. Synclastic is a dome. Anticlastic is a saddle. So showing it more clearly here, monoclastic, single curved surfaces characterized by only bending in one direction at a time. Synclastic curvature, principal curvatures of the same sign, that is the centers of curvature are on the same side of the surface. Anticlastic surfaces in which the centers of curvature are located on the opposite sides of the surfaces. You can see it clearly in the images how monoclastic, synclastic and anticlastic curves are defined and how their shapes are originated. So the answer is because this is a surface has two curvature but both of the curvature is in the same direction, it is synclastic. So the following illustration is an example of synclastic curvature. Question number 3. SkySong at Arizona State University campus is a dash tensile structure, high bar, conic, vault, or inflatable. So Sky Song is a mixed-use project which consists of 1.2 million square feet of office, research and retail space and a hotel conference center. The architects were FTL Design Engineering Studio. The area is 4645 meters square and the manufacturers were Fabritech Structures. What is a conical tension structure? So it is highly effective for covering large areas. A conical tension structure is easily identified by its tent-like shape. Conical designs can feature either single or multiple mass. For both design options, membranes are tensioned between a ring at the pinnacle and the perimeter support columns. Cones are especially effective in areas that need to comply with high rain or snow load regulations. High power or anticlastic structure. As one of the most common of all the tension membrane structures, due to its aesthetically pleasing look, hyperbolic shapes are noted for their excellence with the shape retention and water runoff. These structures rely on two opposing curvatures known as anticlastic for their stability. This type of structure is ideal for a shade over seating areas or high traffic walkways. Parallel arch or barrel bolt structure. These symmetrical curved parallel arch designs form an incredibly functional tension membrane canopy that can span long distances such as a sports arena or smaller areas such as entryway. Depending on the spans, a barrel bolt system can be a cost-effective way to incorporate the tensile membrane on a project due to the repetitive nature of the design and efficiencies of mains. Inflatable structure. Most commonly used as biodomes and for users to set up a temporary exhibition hall using pneumatic air inflating method. So this is how an high power looks like. That is how a barrel vault membrane structure would look like. This is how a conic structure would look like, and that is how an inflatable structure would look like. So our answer is B, conic. Why? Because let's go back to the image again. You see, it is clearly visible that this is a conic shape. So this is a conic tension structure and it is visible from that image. So the answer is conic. Sky Sound at Arizona State University campus is a conic tensile structure. Question number 4. The Millennium Dome in London is an appropriate example of dash structure: membrane, folded plate, pneumatic, diagrid. So Millennium Dome is the large dome-shaped building on the Greenwich Peninsula in the southeast London, England, which housed a major exhibition celebrating the beginning of the third millennium. As of 2022, it is the 9th largest building in the world by usable volume. It opened in 31st December 1999. The height is 95 meters. Architectural style is high-tech architecture. The owner is Anschutz Entertainment Group. Architecture firm is RSHP. Engineer was Ian Liddell. And architects were Richard Rogers and Mike Davis. So, going back to the previous question, what are membrane structures? These are basically structures with thin flexible surfaces called membranes which carry the load primarily through tensile stresses. A structure that is characterized by tensioning of the membrane system, typically with wire of cable, to provide the critical structural support to the structure. As per structural and architectural point of view, membrane structures are light and free-form structures to span a long distance with the minimum material used in their manufacturing. Membrane can be used to construct roofs and facades, freestanding buildings, building envelopes, skylights, indoor ceilings, or accent enclosures. Folded plate structures are assemblies of flat plates or slabs inclined in different directions and joined along their longitudinal edges In this way, the structural system is capable of carrying loads without the need of additional supporting beams along mutual edges. This technique originated in the Germany's in the 1920s, and it became popular to construct roofs for industrial warehouses and public buildings. Modern folded plate structures are typically made of cast in situ or precast reinforced concrete or steel plate. Pneumatic structures. Pneumatic structure is a membrane structure that is stabilized by the pressure of compressed air. Pneumatic structures are characterized by slightly higher pressure of internal air above the outside pressure. These structures are supported by pressurized air within the inflated building elements that are shaped to carry the loads in a traditional manner. The roof membrane of the pneumatic structure is made from rubber or reinforced films using industrial fabrics coated with polymers. A diograte, which is a portmanteau of diagonal grid, is a framework of diagonally intersecting metal, concrete or wooden beams that is used in the construction of buildings and roofs. It requires less structural steel than a conventional steel frame. The Hearst Tower in New York, which was designed by Norman Foster, uses 21% less steel than a standard design. The diograte obviates the need for columns and can be used to make large column-free expanses of roofing. So the answer is the Millennium Dome in London is an appropriate example of, it is an example of membrane structure. If we go back to the image, we see masts and wires and cables holding off the fabric or the membrane. So this is an example of a membrane structure. Question number 5. Again, one image has been provided and you are asked to identify which kind of truss this is. And the options given are Warren truss, Baltimore truss, Harvey truss or bowstring truss. So to understand Harvey truss and other trusses, we need to know what is a Pratt truss. So in Pratt truss, the vertical members are in compression, whilst the diagonal members are in tension. This simplifies and produces a more efficient design since the steel is in diagonal members can be reduced. Warren truss is another very popular truss system and is essentially identified by its construction from equilateral triangles. One of the main advantages of Warren truss is its ability to spread the load evenly across a number of different members. Baltimore truss. The Baltimore truss is a subclass of Pratt truss. A Baltimore truss has additional bracing in the lower section of the truss to prevent buckling in the compression members and to control deflection. It is mainly used for rail bridges, showing off a simple and very strong design. Bowstring truss is a structural device commonly used in bridge building and less often in industrial architecture. It is used to span wide column-free spaces. It consists of an arch beam, the bow, joined at each end by a straight beam, the string. That's why it is called a bowstring truss, with diagonal support beams joining the two. Harvey truss. Harvey trusses are opposite of Pratt trusses in terms of geometry. In fact, looking at a Pratt truss upside down will visualize a Harvey truss. The entire structure is still relatively the same, but the diagonal braces are now occupying the opposite or the unoccupied joints. The switch in position of the diagonal members has a very important effect structurally. So this is how a Warren truss looks like. This is how a bowstring truss looks like a bow and a string and then diagonal supporting it. And then Pratt truss and Harvey truss. Harvey truss is opposite of Pratt truss. And then we have Baltimore truss, which is a kind of Pratt truss, but in the lower part of the Baltimore truss we have more diagonal members, as you can see in the image here. So this is an example of Warren truss. This is an example of Warren truss. Warren truss as in the truss which can be easily identified from its construction of equilateral triangles. Question number 6. In which of the following buildings folded plate structure was used? Bihar Museum, Patna Church of Notre Dame de Royan, France, Yokohama International Port Terminal, Japan, both B and C. So what is a folded plate structure? They are again, as explained in previous question, they are assemblies of flat plates or slabs which can be inclined in different directions and joined along their longitudinal edges. And they can be used in walls, staircases and roofs. This originated in 1920s and became popular to construct roofs for industrial warehouses and public buildings. They are typically made of cast in situ or precast reinforced concrete or steel plates, and they are capable of carrying loads without the need for additional supporting beams along mutual edges. Now coming back to the buildings mentioned, Bihar Museum, Patna, the image has been provided here. Then we have Church of Notre Dame de Royan, France here. We see. Then we have Yokohama International Port Terminal, Japan. So the answer is both B and C. Both Church of Notre Dame de Royan and Yokohama International Port Terminal have folded plate structure. Question number 7. Shenzhen Universiade Sports Center in China is an example of arch structure, folded plate structure, pneumatic structure, dome structure. So this is what Shenzhen Universiade Sports Center, which is also known as Shenzhen Universiade Center, Longgang Universiade Sports Center or Longgang Stadium. It is a multi-use sports facility complex in Longgang, Shenzhen, Guangdong, China. The architectural firm was Gurkhan, Marg and Partners. It opened in 2011 and it is located in Guangdong province. Now, coming back to the terms that have been used in the question, arch structure in architecture. An arch is an opening in a structure that is curved on top and designed to distribute weight. Arches are self-supporting, compressive structures stabilized by the force of gravity acting on their weight, which makes them very stable and efficient, capable of larger spans and supporting greater loads than horizontal beams. Domes are rounded roofs with a circular base shaped like an arc in all directions. It was first used in much of the Middle East and North Africa when it spread to other parts of the Islamic world because of its distinctive form, and dome like minaret has also become a symbol of Islamic architecture. Dome has double curvature and the resulting structure, it is a synclastic curvature. It has double curvature but both the curvature is in the same side, and the resulting structure is much stiffer and stronger than a single curved surface such as a barrel shell. Pneumatic structure, as explained in previous questions, pneumatic structure is a membrane structure which is stabilized by pressure of compressed air. Pneumatic structures are characterized by slightly higher pressure of internal air above the outside pressure. These structures are supported by pressurized air within the inflated building elements that are shaped to carry the loads in traditional manner. Folded plate structures are assemblies of flat plates or slabs inclined in different directions and joined along longitudinal edges. In this way, the structure system is capable of carrying loads without the need for additional supporting beams along the mutual edges. So the answer is that Shenzhen Universiade Sports Center in China is an example of folded plate structures. Now, why? Going back to the image, you can see that these are slabs which have been joined together in inclined ways, and this is how this looks like. So this is not an arch, not a dome for sure, and not a pneumatic structure. It is a folded plate structure. Coming back to question 8. Don't. Question number 8. Which of the following stadium uses membrane structure for its roof? National Stadium of Brasilia, Oldenburg Stadium, Germany, Munich Olympic Stadium, all A, B, C. So membrane structures are a structure with thin flexible surface that carries loads primarily through tensile stresses. A structure that is characterized by a tensioning of the membrane system, typically with wire or cable, to provide the critical structural support to the structure. As per structural and architectural point of view, membrane structures are light. They are free-form structures to span a long distance with the minimum material used in their manufacturing. Membrane can be used to construct roofs and facades, freestanding buildings, building envelopes, skylights, indoor ceilings, or accent enclosures. All these type of parts of buildings or buildings can be made using membrane structures. And as you can see, I have shown different images of different types of membrane structures that have been used in around the world. So this is how the National Stadium of Brasilia look like. It of course has a membrane structure, as you can see in the image around the stadium. Then we have Oldenburg Stadium, Germany. This also has a membrane structure, different from the one in the Brasilia one, but it also has a membrane structure. Then we have Munich Olympic Stadium. As you can see from the image, this also has a membrane structure. So the answer is all A, B and C. Question number 9. US Pavilion Expo 70 is an example of coffer slab structure, air supported pneumatic structure, inflatable pneumatic structure, folded plate structure. So this is what the US Pavilion for Expo 70 in Osaka, Japan looks like. It features a roof covering 100,000 square feet with a clear span of 262 by 460 feet. The total weight of the air supported portion is about 1 pound per square feet. The high strength steel cables up to 450 feet long are arrayed in a diamond grid. There is no tension ring. In plan, the roof shape follows the equation of a super ellipse, an ellipse with square corners. Coffer slab is a ribbed structure with reinforced ribs in the lower zone which have mutually perpendicular arrangement. A waffle slab or two-way joist slab is concrete slab made of reinforced concrete with concrete ribs running in two directions on its underside. The name waffle comes from the grid pattern created by the reinforcing ribs. Waffle slabs are preferred for spans greater than 12 meter as they are much stronger than flat slabs with drop panels, two-way slabs, one-way slabs or one-way joist slabs. So copper slabs or waffle slabs are much stronger than these kind of other slabs like flat slabs and two-way slabs and one-way slabs, and they are preferred thus for spans greater than 12 meter. Folded plate structure, as explained in previous questions, it is a structure of assemblies of flat plates or slabs inclined at different directions and joined along their longitudinal edges. Then we have air supported pneumatic structure and inflatable pneumatic structure. Both of these are two types of pneumatic structures. So in air supported pneumatic structure, they have air pressure higher than the atmospheric pressure supporting the envelope. Airlocks or revolving doors help in maintaining the internal pressure. Air must be constantly provided in such structures. The lifespan of such structures is 20 to 25 years. They are either anchored to the ground or to a wall so that leakage is prevented. They have relative low cost and they can be installed easily. Inflatable pneumatic structure. Supporting frames consist of air under high pressure. Internal pressure of building remains at atmospheric pressure. There is no restriction in number and size of openings. They have potential to support an attached structure. So basically in air supported pneumatic structure there is just one layer, and then we have pressure inside the structure is higher than the pressure of atmospheric pressure. But in inflatable pneumatic structure is like filling air inside a balloon. So the inside of the building also is at the atmospheric pressure, but the structure which is inflated, the inside part of that structure is at a higher pressure than the atmospheric pressure. So the answer is US Pavilion Expo 70 is an example of inflatable pneumatic structure. Question number 10. Baha'i Temple in New Delhi is an example of dome structure, diagrid structure, shell structure, pneumatic structure. So this is how the Lotus Temple looks like, which is located in Delhi, India, and it is a Baha'i house of worship which was dedicated in 1986 December. It is notable for its lotus-like shape. It has become a prominent attraction in the city. The building is composed of 27 freestanding marble-clad petals arranged in clusters 3 to form 9 sides, with 9 doors opening into a central hall. The type is a house of worship. Architectural style is expressionist. Height is 34.27 meters and the diameter is 70 meters. The structural system used in this is concrete frame and precast concrete ribbed roofs. The architect was Faribor Sahaba and the structural engineer were Flint and Neil. So the question was that Baha'i Temple in New Delhi is an example of dome structure, diagrid structure, shell structure, pneumatic structure. So as explained in previous questions, shell is a type of building enclosure. It belongs to the family of arches. It can be defined as curved or angle structure capable of transmitting loads in more than two directions to support. A thin curved plate structure shaped to transmit applied forces by compressive, tensile and shear stresses that act in the plane of the surface. They are usually constructed of concrete reinforced with steel mesh and it functions both as structure and covering. Zaha Hadid is one of the architects who uses shell structures in her designs. Very dynamic shapes she uses in her design and she uses a lot of shell structures and curvatures. A shell with one curve is known as a vault. A shell with doubly curved surface is known as a dome. More complex form of concrete shells have been made, including hyperbolic paraboloids, saddle shapes, intersecting parabolic walls. Then pneumatic structures, as have been discussed in the previous questions, in many of the previous questions. It is a membrane structure which is stabilized by the pressure of compressed air and it is characterized by higher air pressure inside the structure compared to above the outside air pressure. Then dome. Dome is arch in all direction and it has double curvature and the resulting structure is more stiffer and stronger than a single curved structure surface such as a barrel shell. And then diagrid is a framework of diagonally intersecting beams which is used in the construction of building and roofs, and it has been found out that it requires less structural steel than a conventional steel frame. And the diagrid obviates the need for columns which makes thus it can be used to make large column-free expanses of roofing. So the answer is that the Baha'i Temple in New Delhi is an example of shell structure. So going back to the picture again, this is not a dome, this is not a pneumatic structure, this is not a diagrid structure. These are curved shells which have been joined at edges and then this thing has been created. So it has concrete shells. It is made, the structure is made out of concrete shell. So Baha'i Temple in New Delhi is an example of shell structure. Question number 11. Which of the following is not a member of a truss? King post, rafter, purlin, hoop iron. King post is a central vertical post used in architectural or bridge designs working in tension to support a beam from the truss apex above. Rafter is a long board that supports the peak of a roof. Rafters are a type of beam, a heavy supportive board that holds up whatever is above it in a building. Purlin is a longitudinal and horizontal structural member in a roof. Hoop iron is a multi-use steel strip that is commonly used for bracing, non-structural timber and bonding masonry. Now this is an image of king post roof truss. We have rafter here, we have struts, we have purlin, we have the king post. As you can see, there is supporting wall, then we have stone template, then we have the tie beam on it, then we have king post on it, then we have struts holding together the rafters, principal rafters. Then on the principal rafters we have the purlins, and on the purlins we have the common rafter. So the answer is hoop iron. Hoop iron is not a member of a truss. King post, rafter and purlin are all members of a truss. Question number 12. Eden project in UK is an example of folded plate structure, pneumatic structure, space frame, diagrid structure. So this is what the Eden project in UK looks like. It is a visitor attraction in Cornwall, England, UK. It is located in a reclaimed china clay pit. It is dominated by two huge enclosures consisting of adjoining domes that house thousands of plant species. And each enclosure emulates a natural biome. The biomes consist of hundreds of hexagonal and pentagonal ETFE inflated cells supported by geodesic tubular steel domes. The architect was Nicholas Grimshaw. Architectural style is high-tech architecture. Construction started in 1998 and it opened in 2001. The architecture firm was Grimshaw Architects and the service engineer was Arup for this. So we have already explained pneumatic structures and folded plate structures in previous questions. Now talking about space frames. Space frames are 3D lattices structures made up from linked pyramids or tetrahedra into a new layer or 3-layer triangulated framework. Basically, space frame is a 3D truss. And then we have explained diagrid in previous questions too. So pneumatic structures is a membrane structure which is stabilized by the pressure of compressed air, and it is characterized by slightly higher pressure of internal air above the outside pressure. Folded plate structures are assemblies of flat plates or slabs inclined in different directions and joined along their longitudinal edges. Diagrid is a framework of diagonally intersecting beams which is used in the construction of building and rooms. The diagrid obviates the need of columns and can be used to make large column-free expanses of roofing. So the answer is pneumatic structure. Going back to the image again of Eden project, you can see that it is a geodesic dome which is a pneumatic structure. So these biomes are made up of hundreds of hexagonal and pentagonal ETFE inflated cells or pneumatic structures supported by geodesic tubular steel domes. So our answer is pneumatic structure. Question 13. So this image has been provided and you are asked to identify that the shell structure is the former which form: paraboloid, hyperbolic paraboloid, cylindric or conic. Paraboloid is a quadric surface that has exactly one axis of symmetry and no center of symmetry. The term paraboloid is derived from parabola, which refers to a conic section that has similar property of symmetry. Hyperbolic paraboloid is a saddle surface. Therefore, although it is a ruled surface, it is not developable. A cylindric is a three-dimensional shape consisting of two parallel circular bases joined by a curved surface. Conic or a quadratic curve is a curve obtained from a cone surface intersecting a plane. So the answer is hyperbolic paraboloid. As you can see, this structure or shell structure has two curvatures. One is in the other direction, the other is in the opposite direction, which means that this is an anticlastic shell structure, and hyperbolic paraboloid is a type of anticlastic structure which is also like a saddle form. So the answer is hyperbolic paraboloid. Question 14. This image has been provided and you are asked to identify what kind of curvature is this: monoclastic, synclastic, anticlastic or bipolar. So as explained in the previous question, monoclastic surfaces have are single curved surfaces characterized by only bending in one direction at a time. Synclastic surfaces, the principal curvature of the same side, the center of curvature are on the same side of the surface. Anticlastic surfaces are those in which the centers of curvature are located on opposite sides of the surface. So the answer is anticlastic because there are two curvatures and both of them are in the opposite direction. This is an anticlastic curvature. Question number 15. Folded plate structural system can be used for roof, wall, staircase, or all of the above. So applications of folded plate structures includes roof, as you can see in the image, wall, floor also you can see, and staircase also. So it is applicable in all of these four forms. So the answer is all of the above. Question number 60. The structural system used in Yokohama International Port Terminal is membrane, folded plate, grid, pneumatic. So this is how the Yokohama Port Terminal looks like. Osanbashi Pier is the main international passenger pier at the port of Yokohama, located in Naka Ward, Yokohama, Japan. Osanbashi is the oldest pier in Yokohama, originally constructed between 1889 and 1896. It opened in 2002. The architects were Alejandro Zaira Polo, Farshad Mosavi. Main contractor was Shimizu Corporation, TOA Construction Corporation. The height is 15 meters and the floor space is 34,732 meters square. This is how the inside of the Yokohama port looks like. So the answer is the structural system used in Yokohama International Port Terminal is folded plate. Question number 17. One image has been provided and you are asked to identify if it is king truss, post truss, queen post truss, Harvey truss, or Baltimore truss. So king post truss is central vertical post used in architectural bridge designs working in tension to support beam from a truss apex above. A queen post is a tension member in a truss that can span longer openings than a king post truss. A king post uses one central supporting post, whereas the queen post uses two central supporting posts. Baltimore truss is a subclass of Pratt truss, as explained in the previous question. A Baltimore truss has additional bracing in the lower section of the truss to prevent buckling in the compression members and to control deflection. It is mainly used for rail bridges, showing off a simple and very strong design. Harvey truss. Harvey trusses are essentially the opposite of Pratt trusses in terms of geometry. In fact, looking at a Pratt truss upside down will visualize a Harvey truss. The entire structure is still relatively the same, but the diagonal braces are now occupying the opposite of the unoccupied joints. This switch in position of the diagonal members has a very important effect structurally. So this is how the king post looks like. This is how the queen post truss looks like. That is how the